This is Chapter 4 of the WebML course, Models Made from Scratch in this chapter. These are the time codes for the sections, and it's going to mirror the tutorial, except I'm going to add the visual thing at the end. So gather data, perceptron, multi-layer perceptrons, beyond perceptron, and then tfjs-viz API library. How do we gather data? What qualities are important to data for models? And this covers the 4.2 and 4.4.1. And we're going to talk about partitioning data, how there's an eval, a testing, and a training. The eval basically means when you finish all the training section, you see if it's on data that it hasn't seen before, how well it does. The testing is for the end of each epoch and how well it does. And then the training is for changing all the weights on the models. How we obtain data is by using existing data, obtain it manually, which means we send out surveys and we get people to answer them. And then Kaggle open source is we can use open source models like PoseNet or BlazePose, or we can use data sets on Kaggle and put rewards out for them. And then the most expensive option is the third-party option, which is we get another company to do it for us. How many data points do you need? Well, for the models that we're going to be doing in this tutorial, it's about 1,000, and that's for simple things that he teaches us. And then for more complex stuff, hundreds of thousands. And then for the state-of-the-art stuff that are kind of like standard, probably like BlazePose and stuff like that, it's going to be millions. What is clean data? It means there's no missing. They're all the same units, not meters and inches, and there's no outliers. Like if there's something really far out, it's not really good to train your data on that. You could probably cut those out because you're really going for the middle part. Features are things like for the realtor.js in the tutorial, there's like bedroom, bathroom, square feet, and you can choose using your intuition whether you need all those features. You may just need square feet. And we don't use the bathroom in there, so it's probably not an important data set. I don't believe it's in there actually. Bias means that when you are preparing the data, you didn't get enough information. It's like in the linear regression where we're trying to find data points outside of our range. So with the exponential one, there was a range between 1 and 20. And if we go above that, it's going to be wildly different answers. Like we went to 25 and it was already way more off than it was with 7, which was in the range. Perceptron. Here are some tips for the tutorial that would have helped me. Look out for the curly brackets because I missed one when I was normalizing the data and I put square brackets and I got back all once, and that did not help me at all understand anything, and it took a long time to fix. I think it would be cool to save models, but they're easy enough to create, so he showed us how to do it, but he didn't really give us any examples of it. And then some key terms to really listen for are sample, input weights, and activation function. We'll just be using them a lot in the future. Multiple layers. We're going to go beyond what a single perceptron can do. Here's what I learned after going through this whole course, and if I would come back to here, I would try to use tfjs-viz sooner because this is a lot easier to implement on this one, the multi-layered ones. And we learned that a couple layers are better than just one big layer with a whole bunch of neurons or perceptrons. And this is where also we learn it's more about art than science. because we have to have some intuition about how layers affect and how many perceptrons there are. And then I had a problem with making my data for the exponential one. So just look out for that, dot length, you got to put that in there in the for loop and the less than sign instead of a less than equal. I just copied it, so that's that. And then maybe you could train multiple models to gain intuition and compare them. He does a great example of comparing the ones that have on there, and obviously more layers and more neurons, perceptrons, give you a great advantage there. All right, and then he proposes a problem. What if we're dealing with slightly off characters or it's slightly distorted? And that's where we go beyond the perceptron. We go into CNN, and they're filters that are tuned by machine learning. And they're built or tuned so they can find features that are important. And this allows them to find things that aren't in exactly the right place. And that's where things like max polling comes into effect, and you're really able to see more. I would like to see if we're able to distort the images, but we didn't really go over that. And it's kind of like it wasn't that much better than the perceptron, so it was an 89% accuracy compared to a 93 with the convoluted neural network. So it wasn't significantly better where I was like, oh wow, that's a really good reason. And then TF-JS-Viz, it works easily and has a great API. I ran into some problems, of course, and it was very tricky. So here's what got me. That zoom 6 right there. It made the graph so large that I spent like an hour and a half trying to fix it. And I just hoped it would work when I tried. It works great if you just don't have. That's why I say do it in the earlier ones where it doesn't have the zoom 6. But I just made a new ID for that and put that in the canvas, and it worked great. Here's how long it took me to do it. So, learning once fairly quickly, 20, 15 minutes. And then the tutorials each took about like 2 hours each. That's most of that's copying and then trying to find out where I made the mistake in copying. The most fulfilling one by far was the 4.51 to 5.62. That's where like you're running into problems with like technology in the sense that like you're going beyond the limits of what this technology allows. And I really love that. And thank you for watching. Bye.